Right now we're going to cover a little bit different type of pump. This is a vertical turbine that takes its water from a water storage tank, and the pump itself is on a long shaft, and it is immersed in the water storage tank. If we had a water storage tank, and this is what it happens is the pump itself is immersed down there. The impellers are down in the water level, and it comes up to a discharge, and then whatever is driving the pump. The first one we'll cover is an electric-driven vertical turbine. The drive itself is run through a stainless steel shaft that rotates the impellers down here, and there is a coupling here, and then as it comes up through, the motor itself has a hole in it to accept the top shaft that comes down and ties all of this together. Once we've dropped the fire pump in, because this is not going to be on there, you're going to be able to go ahead and set that down in there. What I would recommend doing is leveling up off of this, and once you've gotten this set down into place, I would put something over the discharge hole that's there. It's very convenient for things to get dropped down inside there. Pop cans, cigarette butts, who knows what, flange bolts or anything else could wind up down in here. If something does wind up down inside there, then you need to take this back out again and clean it out, whatever it is. So if we cover this up, that should eliminate some portion of that. This is an electric-driven pump. The shaft that fits down through there is the top shaft, and it has a right-hand thread up on the top. It has a left-handed thread down here, and with this coupling it winds up having a locating hole in it, or a centering hole. So that way there, as this is screwed onto this shaft, we can make sure that it hits the center, so the two of them are going to wind up butting together. And the reason that locating hole is in there, so we don't wind up with way too much thread up in one part of the coupling and then not enough in the other, and it may put a strain on it and strip the threads out. So that's the reason that's that way. With the electric driven, it has an anti-reverse ratchet on it, so it will only rotate one way. And as we're dropping this down in there, we need to take a file, because as you're looking at the hole that the top shaft fits down in there, there may be some burrs on this. So we want to go ahead and before we put the top shaft in there, clean that out with a good file. If we're looking also at the top, there's usually 4 small set screw holes. We need to make sure that we either make a pencil mark or some type of a locating mark like that on the outside. Once we've gotten that set and this has been bolted down, make sure that you tighten that up good. Most of the time, the bolts that come with that are case-hardened bolts, and they're usually coming in a small sack or in a box somewhere. You want to make sure that you get the proper ones that are used in there, because there's a tremendous amount of torque from the engine when it starts up, or from the motor, not the engine. Once we have done this, we need to take the top shaft, and it also, if you're looking at it, it has the same type in there, so we want to go ahead and clean that up and with a file before we go ahead and drop this down through here. Once we've done that, there's a small hook-shaped key, and we want that key to drop into the keyway, letting it go and let it fall all the way down. So whatever it takes as far as filing this up, because we've cleaned this, We want to make sure that it's a clean drop in there. If you try to even drive that in a little bit, if you ever have to take that back out again, you're going to wind up having to take the anti-reverse ratchet apart and everything else like that, and to wind up getting the key out of there. With the electric driven, we'll go ahead and do all this cleanup work, drop the key in there, make sure it goes down in there. There's a larger hex nut or octagon shaped nut that will wind up tightening it up, and we're going to do what we call setting the lateral. As we run that down in there, and if you're looking at the top part of the anti-reverse ratchet, the shaft is sticking up. What we want to do is measure this distance from here up, and we want to lift it about 1/8 of an inch. And what that's doing is it's taking the strain off this where the impellers are resting down in the bowls down in there. What we're going to do is we're going to lift that up about 1/8 and take those up and suspend them. Once we have done all of this, then we want to go ahead and take the nut off, take the key back out, put those somewhere where they won't get lost. And because what we don't want to have happen is this, because this is a 3-phase motor, there's a possibility that it could be rotating the wrong way. If you look on the base of the pump itself, if we're looking at this, and this is the pump, these are our tie down bolts and all of that. If you'll look in there, there's usually a rotation arrow that's cast into the base itself. And by taking the key out of there, and when they bump it to check for rotation, there's a possibility it's turning the wrong way that way there. If that happens, with the key out of there and the nut out of there, it's able to rotate freely and not have a problem. If you accidentally leave that in there, you could have a disaster as far as some things getting broken and that. Also, and it's not to that they're concerned about your workmanship or anything like that. If you do that, your startup guy is going to come out and he's going to do the same thing again. And what he's doing, he's just covering himself to make sure that yeah, he's indeed checked, setting the lateral on that. So on electric, we're going to take all of this apart. If it's diesel driven, this is going to be replaced. With what we call a right angle gear head. Same idea. The only thing is that what we're doing is we're going to take the diesel driver that may be located over here, and we're going to have an output flange here. It'll be either an output flange or directly to a flywheel here, and this is going to be tied together with a drive line. This one has universal joints in that. It doesn't make any difference which one of these is higher, but one of them needs to be higher than the other, and it depends on the length of the drive line. I know that Peerless uses a short drive line that's less than 1 foot long, but some of the other Fairbanks and some of the other ones use longer drive lines. So with this one here, if it's a short drive shaft, we're going to wind up only having about 1/4 of an inch offset. We want to make sure that these U-joints work. We don't want to have them same center line and all of that. It'll cause the needle bearings to wear out quicker. We want to make sure that we do have a difference in elevation to make sure that the drive shaft does work. Setting the lateral is going to wind up being the same way on this, but once we have completed that, we can finish the installation and leave it. We know that the diesel driver is only going to rotate one way. That's not going to be an issue.